All right, this section is called the coffee and donut problem. So what we've been doing in Unit 2.3 is we've been looking at ways of finding the solutions to a system of linear equations, or the intersection point between two lines. What we're going to do in this set of problems here is we're going to visualize how we can solve a system of equations by subtracting those two equations. This is kind of an introduction to the technique known as elimination that we're going to look at in the next section. So let's just jump in and see what coffee and donuts has to do with all of this. So yesterday, Ms. Zarati needed 3 Timmy's coffees and 2 donuts to get the day started. That cost her $8.75. Today, Ms. Zarati only needed 1 coffee and 2 donuts, which cost $4.25. What is the cost of a coffee and a donut? We are going to start by representing this problem in pictures. So for day 1, you can see that we have 3 cups of coffee, we have 2 donuts, and our bill was $8.75. Day 2, we've got 1 cup of coffee, we've got 2 donuts, and our bill was $4.25. And the key to solving this kind of problem is to look at what is the difference between the 2 days, or the difference between our 2 orders. So we've got 3 coffees and 2 donuts, 3 coffees on the first day, 1 coffee on the second day. The difference between those 2 orders is 2 coffees. And in fact, that's the only difference in terms of what she bought, because we had 2 donuts on the first day and 2 donuts on the second day. So the only difference between day 1 and day 2 is 2 coffees. But that ends up giving us a difference in the bill on those 2 days. So our first day, our bill was $8.75. On our second day, our bill was $4.25. The difference in cost between these two was $4.50. So these 2 coffees must represent that difference in price. These 2 coffees must cost $4.50. So if we want to know what 1 coffee costs, we have to just take that difference and we're going to just divide it by 2. So 1 coffee is going to be $4.50 divided by 2, or $2.25. Once we know what 1 coffee costs, that's $2.25, we can take a look at this order from day 2 and we can work out what 1 donut must cost. Because if it's $2.25 for a cup of coffee and our total bill is $4.25, these 2 donuts must represent, well, whatever isn't made up by the coffee. So if we've got $4.25 in total, we subtract off the $2.25 from the coffee, we're left with $2 for our donuts. Now, this gives us 2 donuts, so 2 donuts, we'll just write 2 donuts over here. So 1 donut must be that $2 divided by 2. So the price of a donut is $1. Okay. Now, we've done this using pictures. We can also do this using just algebra rather than pictures. So let's take a look at what that might look like. Okay, we're on page D2 here. So rather than drawing pictures of my cup of coffee here, I'm just going to use C to represent the number of cups of coffee. And I'm going to use D to represent my number of donuts. So my order on day 1 here, or Ms. Zarati's order on day 1, is 3 coffees, 2 donuts, and this adds up to $8.75. Okay. Now, in saying what C and D are, I've been a little bit lazy here. I really should say that C is the cost for 1 coffee, because 3 times the cost for 1 coffee plus 2 times the cost for 1 donut is $8.75. I mean, C and D represent the cost rather than the number of coffees or the number of donuts. Anyhow, our second day here, we have 1 coffee. So 1 times the cost for 1 coffee plus 2 times the cost for one donut, D, adds up to $4.75. And if I'm interested in the difference between the orders, like I was on the previous page, difference means subtract. So I'm going to subtract these two equations. And notice that, oh, I made a little mistake here. So I'm going to come back and erase this. This should be 425 rather than 475. That's a little better. So now, notice I've got like terms lined up with each other. So I can just subtract 3c minus 1c. They're like terms, so 3 minus 1 is going to give me 2c. 2d minus 2d, those are just going to cancel each other out. And on the other side of my equal sign, 875 minus 425 is going to give me 450. So if I want to solve this little equation here, 2c equals 450, solve it for c, I'm going to divide both sides by c. c is equal to 225. So that c, which is the cost for one coffee, must be $2.25. Once I know what c is, I can then take a look at this order from day 2. It is, as I said, 1c plus 2d is equal to 425. I know what c is, so I'm going to replace 1c with 225. And now I've got a little equation here that I can solve for d. I'm going to, let's subtract 225 from both sides. Okay, to get d, I'll try to get d all by itself. So 2d is going to equal 425 minus 225 is just going to be 2. Give ourselves a bit more room here. And then to solve for d, I'm going to divide both sides by 2. And I'll get d is equal to 1. So d represents the cost for one donut. That's going to be $1. All right? So let's take a look at another example. And we'll use the same kind of technique where we're going to have two. The key to this kind of question here is that the number of donuts in this question here was the same. Okay? When the number of donuts is the same, it's pretty easy to solve, okay, because the number of donuts kind of cancel out. Orders here, and we're going to look at the difference between the orders again. So 2 lattes and 2 cookies cost Miserati $7.10. 5 lattes and 4 cookies cost $16.95. Determine the cost of a latte and a cookie. So we visualized our two orders here. 2 lattes, 2 cookies, $7.10. 5 lattes, 4 cookies, $16.95. Now, there's a problem here that we didn't have in the other one. Let's go back. In this one, the number of lattes is not the same and the number of cookies is not the same. So we have a bit of a problem. But what we can do here is we can double the order, this first order. Okay, so instead of having 2 lattes, we can draw a little picture here. We can add ourselves 2 more lattes, so now we have 4 lattes. But more importantly, we'll now have 4 cookies. Now the number of cookies is the same. And if we've doubled the number of lattes and we've doubled the number of cookies, times 2, times 2, we also will double the bill. So our bill will now be $14.20 for 4 lattes and 4 cookies. Now, when we look at the differences between the orders, the number of cookies are the same. The only difference is 1 latte, 4 lattes versus 5 lattes. So that 1 latte must be responsible for the difference between the two prices. So $16.95 minus $14.20, we pull out our calculator, we do that subtraction, we get $2.75. So that 1 latte has to be $2.75. Once we know that a latte is $2.75, we can go back to this first day order, which is 2 lattes. We now know that these 2 lattes cost us $5.50, $2.75 times 2. These 2 cookies, on the other hand, have to be whatever is left over in the bill. So our 2 cookies must be this $7.10 minus the $5.50. So 2 cookies are going to be $7.10 minus $5.50 is 1.60, 160. So 1 cookie, just dividing by 2, has got to be 80 cents. So we did this visually. We could also have done this using algebra. Okay, we can use, let's say, let L, capital L, be the cost of a latte, or the latte cost. And we're going to let capital C be the cookie cost. Okay, so let's represent our first day here with, in terms of L and C. Well, we're going to have 2 lattes and 2 cookies is going to give us $7.10. And if we're representing day 2 here, or this second order, we've got 5 lattes and 4 cookies is $16.95. Now to solve this, we didn't use 2 lattes and 2 cookies. We took that order and we doubled it. So we took all of this stuff and we multiplied it by 2. So our 2 lattes became 4 lattes. Our 2 cookies, again multiplying by 2, became 4 cookies. And our $7.10 became $14.20. And it's these 2 equations right here that we're going to use to do our solving. So we are going to take these 2 equations, and again, we are going to subtract them. Okay, we've got 4L minus 5L. We've got our like terms lined up again. So 4 minus 5 is going to be negative L. 4C minus 4C, just gone. And 1420 minus 1625 gives us negative 275. If negative L is equal to negative 275, we can divide both sides by negative 1 here to get that our latte is $2.75. Once we know that a latte is $2.75, let's go back to this order that we had here on our first order. We know that 2L plus 2C, so 2 lattes and 2 cookies, is $7.10. Let's put in the price of 1 latte. Okay, now we've got an equation that we can solve for C. We're going to start by multiplying the 2 times the 275 to get 550 plus 2C is 710. We're going to opposite operations, same thing to both sides, minus 550 minus 550. That's going to give us 2C is equal to 710 minus 550, 1.60. And then again, opposite operations. We're going to get C all by itself, divide by 2, divide by 2. C is 0.80. So again, our latte is $2.75. Our coffee, each cookie, must cost 80 cents.